Hi, did you know that you can convert your phone into a wireless IP camera, stream live into your PC, and with OpenCV do live image processing like motion detection, etc. on it? In this video, not only will you learn to do that, but we'll build a smart intruder detection system on top of this. This system will record a video clip whenever someone enters into your room and then save that video clip into your PC with a timestamp. And it will also send you an alert message via the Twilio API. We'll learn to do all of this in this entire video. So let's get started. For this video, I'll be following this blog post. I've actually written this post a year back, and it's very detailed regarding the whole processes that's involved to create this whole application. So this tutorial can actually be split into 4 parts. In the first part, we're going to learn how to access live camera stream from your phone into your PC and access it with OpenCV. And then in the second part, we're going to learn how to use the Twilio API to send SMS. And in the third part, we're going to build a motion detection system using background subtraction and contour detection. And in the final part, we'll combine all of these 3 things and create our final application. All right, let's start. So the first thing that you need to do is download this application called Ip Webcam from the Play Store. I'm using Android phone for now, but I assume that there will be an application like that in iPhone too. So make sure to download an application that says Ip Webcam or something like that. So this is the icon and this is the name exactly which I have downloaded in my phone. I think this will also work with other IP camera applications too. All right, just as a recap, we're going to be using the OpenCV video capture function. Most of the people are familiar using this function to process videos or to access a webcam, but a lot of people don't actually know that they can also, stream IP camera feeds with this function too. By the way, you can also stream a GIF with this. So these are some of the things that most of the people are not familiar with. Again, you can go over this blog post, which goes into a lot more detail and cover a lot of the things that might be useful for you. All right. So after you have installed this application from the Play Store, what you can do is open it up and scroll to the bottom, and then you will see something like this, an option saying Start Server. So you need to click on this button. When you open this application, it will be in the bottom. All right, after you click on it, you will see an interface like this. So right now I have this application running, and when I click the Start Server button, I'm gonna see something like this. I hope it's fine. All right, so as you can see, this is what I'm getting right now. So this is what I'm seeing, and this is approximately the same interface which you're going to see right here. So here you're going to see a live video feed, and then you're going to see a bunch of IP addresses like this. What you need to do is copy this IP address, whatever you're going to see here, and then you can paste that exact address in your browser. So once you do that, you're going to see something like this. Let me just show you here. So you're going to see something like this. So this is the whole interface that this application is giving you. You have a bunch of options here. You can zoom in, you can set the stream quality, exposure, compensation. You can select between the front camera or the back camera. There's a default motion detection system between here, which has a sensitivity. And then there's a lot of other controls that you can go over. But right now, what I'm interested in is just getting access to the basic video feed from this camera. So I need to click on this browser option, which will open the video feed in the browser. So this is what I'm looking at right now. Like I said, I can do a lot of things. I can change the camera settings, like I can access the front camera or the back camera, change the resolution, exposure, and a lot of other things. I can walk around with this. So this is how you're going to view your mobile's live camera feed into PC. And by the way, I can also, close off my mobile and it will still work. So this will still work. I mean, so this will actually act as a spy camera. So even the fact that my camera is is blank here, so my phone is blank, but the camera is still working. This will probably you can just put it somewhere in your room and it will work as a spy camera for this whole intruder detection system. So this is pretty cool. So now that I have my camera running, what I need to do is how can I access this with OpenCV. So all you need to do is put this URL, exact URL, in the cv2.video capture function in OpenCV and just add a video tag here. So this is all you need to do to access it with OpenCV, and the rest of the code is pretty much the same what you put when you're working with videos in OpenCV. So this is, I'm just making the video normal so I can create the video in full screen, and this is the code for calculating the FPS. And then I'm reading the frame bit by bit. If the frame is not read correctly, I'm breaking the loop. And then I'm appending the counter, and then finally calculating the whole frames per second FPS and displaying the FPS by putting it on the screen, and then finally showing the video frame. And then if I press the Q button, I'm going to break out of the loop, and then I'm going to release the camera and destroy the windows. So this is the whole code for that. Before that, I need to first run the imports, and then I'm gonna start. This notebook will be available if you can download this notebook from the link in the description. All right, let me just run this. So this is as you can see, this is the code is pretty nothing. All right. As you can see, it's live here, and the FPS is visible, and the camera is working pretty much fine. Sometimes I feel it gets stuck for a second or two, but then it starts working again. And by the way, the other thing I'm also doing here, and I'm calculating the average FPS. As you can see, most of the times I'm using a different approach to calculate the FPS, and I'm calculating the average FPS for this particular application because sometimes there will be a lag. So I need to get the average FPS for all the frames. So this will give me a more appropriate measure of FPS. So this is the reason that I'm calculating the FPS with this particular method. All right. So this is the thing that you need to do to access your IP camera with your phone. So once you have this working, there's a couple of options that you can set. So open up the Ip Webcam application and go to the video preferences option. Here you can change the camera, either select the main camera or the secondary camera, change the video resolution. The default resolution will be the 640 by 480, which is I think the default resolution that OpenCV also uses your webcam with. So this is good enough for me for this particular application, because the lower the resolution is, the faster the FPS you will get. So if you try to increase the resolution, the speed would also decrease. So you need to pick up the ideal resolution for you. For this particular case, 640 by 480 is the working for me. And there's a bunch of URL options that you also have. So by default, we are using this particular format. This is the host, A192.163.3, and this is the port, and then this is the video tag to access the video in MJPEG URL format, right? But if you need the audio of that IP stream, you will use this particular format. So you can simultaneously use multi-threading, and then you can get the audio, you can get the video, and do a lot of other things with that. And this is the URL if you only need to access that image in that particular time. And so so there's a lot of things that you can do. Notice all the options here in this browser. So these are all the options that are configurable in the application itself. So if you're going to use OpenCV with this stream, what you need to do is configure those settings inside the application, in this IP camera application, and then start the stream. So this is how because with OpenCV, you can't set all these settings inside OpenCV. OpenCV doesn't give you options to do all that configuration. So this is why you need to set this configuration. This is just some extra stuff. Don't need to do any of this to run this application. The default values that you're going to get is just fine for this application. All right. All right. Moving on to the second part, sending messages with the Twilio API in Python. So this is all the code that you will need to send messages. But before I go into the code itself, let me show you how you can set up the Twilio API. So what you first need to do is, you open up this blog post, and we're going to scroll down to this section. So the part 2. So what you need to do is first sign up here. So once you open this URL, you're gonna see something like this. So you need to add your first name, last name, sign up. And after you sign up, you go to the dashboard, and then you're gonna see something like this. So you're gonna see this particular interface. So with this interface, what you're gonna get is this account SID. And then you're going to be giving this auth token, which you can get by clicking here, show, and then you're going to get this auth token. And then you're going to get this phone number. This is the trial phone number. So once you open an account with Twilio, you're going to get a bunch of credits. So you can see my trial balance is here. Your balance will be a little bit higher, as every time you send a message, some balance will be deducted from here. So every time you send a message, a couple of cents would be deducted from here. And once your trial balance goes to 0, you will need to upgrade to an account. Furthermore, you can get other numbers too. So you can upgrade to buy more numbers. These are the numbers that the messages will come from. So when you get messages in your phone, you will see that this is the number that the message came from. So this is how this works. So this is the trial number. And when you first, sign up, you might not see this trial number, but you will see a button here saying get a trial number. You will need to click on that button, and then you will need to, confirm that you need to, that you want a number. And once you hit the confirmation option, you will get this, you need to refresh, this console, and then you will see this trial phone number here. All right. So there's one last thing that you need to do, is that you need to scroll down to this post, and then you will see this link here. You need to add your phone number from which you gonna receive the messages here. So these are the numbers where the messages will go to when you send the message. So this is the verifier caller IDs. With the trial account, when you sign up, you're going to get a trial account, and with a trial account, you can't send messages to any random number. You need to register that number first. So I have registered my number here with Twilio. So this way I can send messages with using that trial number to my number. So this is how this is going to work. Again, with the trial account, this is a limitation that Twilio has on your account. So once you upgrade, you can send the message to any random number. All right. So once you have these 4 things, you have done the 4 things. You have, added your number, which is where you're going to receive the messages to Twilio. That's one. And then you have the 3 things. You have the auth token, you have the account SID, and then you have the trial number. So these are the 4 things that you will need. So what you're going to do now is create a text file. The text file will be called credentials.txt. So I have a text file here. Let me show you. So this is the text file. By the way, you're going to get this entire folder when you download the code. So you're going to get a default credentials file, but obviously the credentials would not be real. You will need to add those your own credentials. So this is the credential file that you will get. So within the account SID, you will add the SID here, and then in the auth token, you will add the auth token here, and then you will add the trial number here, and then you will add your own number here. One thing that I should tell you that, when I was testing, I was confused about it a little bit. You don't need to, insert the plus icon. So you don't need to add the plus with the number. Just insert the number directly. Don't add the plus. So otherwise it won't work. All right. So these are the 4 things that you will insert in this credentials.txt file. And after you have done that, you will save this credentials.txt file. So this is all you need to do. Add these 4 things inside the credentials.txt file and save it. So that is it for this part. And the second thing that you will do, obviously, is install the Twilio API by doing pip install Twilio API in your command line. So just use cmd pip install Twilio. All right, because I have done that, this will say that it's already installed. Right. So that is all that you need to do to install and configure the Twilio so that it works on your system. Now let's get into the code. So once you've installed Twilio, you can do this. from Twilio.rest import client. So you will import this client class, and then you can use this client class to send messages. But before that, you need to import the credentials by reading that file. So by the way, you can directly put those credentials in this Python code, but I'm not doing that because I want this code, because then you will need to change the code and for every person. So you can, if you have a file, because this is a common practice, if you have credentials, you put it in a file and then you read those credentials from a file. So this is a good practice because you can work with many different credentials for different applications, and the code will remain the same. You will just need to change the file name. So as you can see, I'm using credentials.txt, which contains the actual credentials for my account. I won't be giving you this file, but you will get another file, credentials.txt, and you will need to add your credentials there. So I'm reading up this file, and then I'm storing all those variables inside this info dict. So the whole file is designed in a way that once you run the eval method, the whole credentials will be saved in a dictionary Python format. So once it's saved in a dictionary format, I can get the account SID by doing this, and I can get the auth token by doing this. And then once I've extracted the account SID and the auth token, I can initialize this client class by running this command client account SID and passing it the auth token. And now my client class is initialized, and I will call the method called client.messageCreate. This will create and send the message. And all you need to do, because you have already initialized this, all you need to do right now is pass in your number to which the message will send to, and the trial number from which the message will arrive. So this is the trial number. So as I said, we've already loaded up the credentials, and so we can easily access all those things by because it's a Python dictionary, by passing it the key, and we're gonna get the value. And the final thing that you need to pass in is the text body. So I'm just passing it in a single message, "What's up, man?" You can pass it anything. You can even insert Python variables here, which is what we're gonna do when we're gonna run the final application. So this is all the stuff that you need to do to send a message. So once I run this, I'll get a message in my phone, "What's up, man?" So let me just run this. All right. So if this runs correctly, you're not going to see an error. So if you don't put up your number correctly, or any of the variables are wrong here, the token, you're going to see an error message printed below. So because I've run this, I'm going to receive a message. Let me just show you the message I've gotten. I've received. All right. So as you can see, I've received this message here. I'll show you that screen here. So I don't know if it's visible or not. Maybe it's, yeah. So it's blurring it out. So yeah, as you can see, this is the message. It's being reversed, so you won't be able to exactly see here. So anyways, so "What's up, man?" I'm getting the message, and there's a written on the top. It's written sent from Twilio trial account, and this watermark or this will be removed once you upgrade to a paid account. So this is all that you need to do to send messages with Twilio. And once you upgrade, you can even send WhatsApp messages and do a lot of other things. So this is a very interesting API. All right, in this part, we're going to build a motion detection system using background subtraction and contour detection. I've actually covered this sort of approach in a previous video in which I did the same exact thing, but for detecting vehicles. So this is the post. This is the entire video. You will find it in my YouTube videos. And so this is the vehicle detection system. In this video, I used the exact approach that I'm going to show you now. But this time we're going to be detecting people instead of vehicles, because this approach is so generalizable. We can do the same thing, but for different objects like people. So I'm going to be reading this sample video for the rest of the tutorial. I'm not going to be using the same IP link, just for showing you the demos work properly. But in reality, when you run this application, you will want to use that IP stream to run the application. But for testing purposes, I would strongly recommend that you record a video and then you test all your functionalities on that test video. And once you have a system and scripts that are that work for you, then you work on the IP streams. So this is how this works. So I've recorded a sample video of me coming into a room, like picking up a few objects and running away like an intruder. So this is what I've recorded. So I'm going to be reading this video. And then what I'm going to do, so I'm going to be initializing this background subtraction method, which is a pretty robust method in OpenCV. And I'm going to set detect shadows equals to true, which is going to make sure that shadows are also detected. And these are the variables which I'm going to be setting up. I've discussed all of this, all these variables in detail in that video, which I previously mentioned. So now what I'm going to do is I'm also specifying a noise threshold. This will help me reduce the noise and filter it out. So this is useful threshold, and I'm going to be using it in the code below. All right. So now I'm going to start reading the video frame by frame. I'm going to apply the background subtraction method on each frame. Then I'm going to filter out the shadows by calling a threshold method. By default, you're going to get the shadows in gray color. So, and then you can filter out those shadows, by calling the threshold method. And then what I'm going to do is you run 4 iterations of dilation. And this is just true for my case. These are the morphological operations, which is erosion and dilation. And what erosion does is reduces the white substance, and what dilation does, it enhances the white substance in a processed mask. So these are the 2 operations that you will need to pre-process correctly. For my particular scenario, I needed to run 4 iterations of dilations, and I didn't need any erosions for this particular scenario. Again, this will vary from video to video. So you will need to figure out what particular configuration works for you. It's not a difficult task. I mean, you just run the video feed, sample video feed, and then you figure it out what's working for your particular scenario, what's working for your particular lighting setting in the room, and things like that. So once I've got this mask, again, I've covered all this in detail, how to pre-process stuff like that in this vehicle detection video. So I would strongly recommend that you watch this video to understand all the details behind the intuitions that you will need to figure out the variables. So once you've done that, what you will do is apply contour detection. So once you do contour detection, you will get contours, and once you have contours, you will extract the maximum contours, because we're only looking for a single intruder. You can have multiple intruders. Then if you're going to have multiple intruders, you will also need to. It will still work for multiple intruders if you in fact draw a bounding box around a single intruder. But if you're working with multiple, you, instead of getting a max, you can get the top 2, top 3, or top 4, or any number that you want. So once you've extracted the maximum contour, I'm gonna check if it's above a certain threshold, because if something is moving, if a tissue paper moves around in the room, that is also going to trigger some motion, and there's also going to be some white on that because of the motion detection system. So you need to ignore those things. So in my video, you will see that. Let me show you the video here, so you have a clear idea of what we're working with. So let me show you the exact video. So this is the video. As you can see, let me show you the results of these. Why not just run this exact results? So let me just run this, and you're going to see the exact thing. So I've stacked both of these side by side. As you can see, these are the white spots. This is a noise, all the noise that's appearing because of the light variations and stuff like that. And as you can see, the sheet in the bed is moving because of the fan is working. So there's moving parts all around the video due to light variations, due to wind blowing and moving parts around. So this is all the noise that you have to deal with in the real world. So, and these are the processing. I'm using dilations. I'm using, getting rid of the shadows and checking a threshold in order to, cancel out the noise and only draw a bounding box around the actual main moving object, which is me. So this is how this is working. So once I have, made sure that the object that I'm getting is a big object, it's not just some noise, then only then I, get a bounding box around that contour. And using those coordinates, I draw a rectangle around it, and I also put up text on the video that a person is detected. And then what I'm just doing is stacking the actual frame with the segmented black and white frame which you just saw together. So, but before I do that, I need to convert this black and white mask into 3-channel, because stacking only works if the channel matches. So once I have this stacked version with a black and white processed image and the actual video feed, I just resize it a bit to fit it on the screen, and then I'm showing it to you. Now let's put all the things that we have learned together and create a final application. Alright, so first of all, what we're going to do is create functions for sending messages and for detecting motion. So two of the things that we've learned is how to use the Twilio API to send messages. So let's put the code into a function, and this is what I'm going to do this with this particular piece of code. All this code is doing is, this is a function for sending messages, and this is the same code that we have covered above. So we are getting the account SID, extracting the auth token, initializing the client, sending the message here, and I'm passing the text body to this message. So I just need to call this send message function, pass in the text, that exact message that I need to send, and the message will be sent. So this is this whole function right here. We have already understood how this whole thing works, right? And for the motion detection, I have created another function which detects if a person is present or not. And again, this is the same code that we have covered above. I've just put it in a neat function, all the code. So this is it. What I'm doing is passing in a video frame and then specifying a threshold. So this is I've set this threshold as a tunable argument, so that I can shuffle around with different thresholds if the algorithm is not working correctly for me. Anyways, so what I'm going to do is apply the background subtraction again, do get rid of the shadows, perform dilation, do contour detection, make sure there are contours detected, and contour area is greater than some particular threshold. And then and only then I'm gonna extract the maximum contour, draw a bounding box around it, put the frame, and return a boolean variable called true. So this is indicating that the contours were detected, and if the contour is if the person is not detected, then I'm going to return false. And along with that, I'm also going to return the actual annotated frame. So in that frame, a bounding box will be drawn, and there will be written person detected on the screen. So these are the two things that I'm returning with this function. Now that we've initialized, let me just run these functions. So now that we have initialized these two functions, all we need is an application, is a code that reads frame by frame from that IP camera stream. And what it does is this function calls this function, right? Is person present. So whole script is going to call this function is person present, and if that person is present, what we're going to do is start a video writer. So what video writer in OpenCV is this particular piece of code. Let me show you the exact video writer code here. So this is the video writer class here. What this does is this enables you to write videos or save videos in your disk with OpenCV. So what is our objective? Let me go over our objective again. So our objective is, whenever someone enters a room, we start recording a video of it. And whenever someone leaves the room, we finish our video and save it on our disk. So and the other thing that we will do is, once the person is gone, we're going to also send an alert message to our phone. So to put it into the code logic, to put all of this into code logic, what we want is, whenever motion is detected, right? So we're going to call this function is person present. Whenever this function is going to tell us if a person is present or not based on the motion detection, right? Based on the motion. If there's motion, then probably a person is passing in. So if there's motion, start recording. Say initialize the video recorder and start recording. And whenever the motion stops, which means the person has exited out of the room, so finish the recording and then send the Twilio message. So this is the whole code logic, and this is exactly what I am doing in this whole piece of code. But I'm doing one or two things extra in this to improve this whole logic. So, and I'm going to tell you a reason why I'm doing those things. So, but the essence is, this entire logic is the same. Whenever someone enters a room, whenever there's motion, start recording. Whenever there's no motion, finish the recording, save the whole video in the disk, and send a message via Twilio to a person's number. So this is the whole thing. That's the entirety of it. But there's a bunch of catches, things that you need to make sure that are taken care of. And I'll tell you what are those issues here. So here's an issue. If I design this code in a way that the video writer has to reinitialize and start recording whenever a single motion is detected, then what happens if there are false positives? Because there will be false positives. Whenever you're building an object detection system, there's a lot of chances that there will be false positives from time to time. And because the whole system is based on motion detection, it's not like a very robust deep learning approach that is set up in a way that has a high confidence and stuff like that. So anyways, if you have a system that is entirely based on motion detection, there will be false positives and you need to handle those conditions. So I can't afford to start recording every time there's a false positive. So but what I can do is apply a condition such that if there is motion in suppose 7 to 8 consecutive frames, if I detect motion in 7 to 8 consecutive frames, then definitely there is someone present there. Someone has entered into the room because I am detecting motion in each 7 to 8 or 10, any threshold value. I am detecting motion in n consecutive frames. So this is one piece of logic that you need to take care of, and you can take care of by setting a threshold to initialize a video recorder when the threshold of frames are detecting motion. So that's one piece of thing. And the other thing that you need to take care of is false negatives. Even if someone is present in the room, there is a chance that that person will not be detected in every frame. So what happens if I'm recording the video at 25 fps, and for one particular 2, 3 or 4 particular frames the motion detection misses me, or even if I stop there for a second in a video and if I disappear out of the frame, what will happen then? I don't want the video to stop, and because if I do that, what will happen then is that the video will stop, it will send me a message, and again when I start moving again, it will start another video, and if if the frame does not detect me, it will save it another video. And because of this particular fault, what will happen if a single person enters your room and he makes several stops, or the algorithm misses a few detection, for each person you will get like 4 to 5 or 10 videos, and videos you will also get 4 to 5, 10 messages. And this is like spamming your database and your message. So you need to handle those conditions. The ideal scenario is that for a single person, you want a single message and a single video. So you need to handle the false positives, which we've already figured out how we can do that. And then to also handle false negatives. These two things that are something that you need to take care of. So to handle the false negative scenario, I am initializing this variable called patience, and it's set to 7. Now what this logic is going to do is that I'm going to just show you this entire logic here, the patience logic here. So let me just first explain this, and then I'm going to go over each line of briefly going to each line of code. The main thing is that you understand the whole concept. Once you understand the whole concept and the whole code logic, the rest of the code is already highly commented, and you can easily figure it out what's happening once you understand the whole code logic, right? So I'm handling the false negative cases by initializing this patience variable, and this patience variable is set to 7, and this 7 actually means 7 seconds here. So what I'm going to do here is, once a person is not detected in a frame, so let me explain the logic behind it. So consider this. If a detection is missed, a person is present in the room, but for the next few frames, because the person is standing still, the motion detection is not able to pick up that person, or maybe the person moves out of the camera view and the person disappears for a few seconds. So what we are doing here is I'm initializing a 7-second window, and this is the wait period. So if the person disappears or if a person is not being detected, I'm going to wait for 7 seconds. Now, if the person is detected again in that 7-second video, I'm going to continue on with that video. I'm not going to stop it. But if the person does not reappear within those 7 seconds, I'm going to stop the video and I'm going to send the message that, alert message, and I'm going to save that video separately. So because if the person does not reappear for 7 seconds, I'm going to assume the person has exited out of the room. You can increase this patience value according to your scenario, but for me, I thought that 7 seconds were enough to determine if the person has exited the room. So this is the entire logic, entirely what's happening in this piece of code. And if you want the total number of lines, so these are like, let me show you the exact number of lines here. So So this is what happening in 133, plus you can add on to, like, this is like 33 plus 12, so approximately it's like 180, 190, 200 lines of code. So this is the entire logic which I've just explained is happening in this 200 piece of lines of code. So if you understand what I've just explained, you don't even need to understand each and every line of code, because that's entirely what's happening, and every line is highly commented. So if you understand this particular logic, you can rewind the video and go over this logic again, which I've just explained. So once you understand this logic, all this code is you will get it instantly. So all this code is commented, and it's the same logic which I've just covered. But for the sake of this video, I'm just going to briefly go over all of these lines in this cell. So let's start. So first I'm initializing the name window, I'm initializing the capture, I'm getting the width and the height of the camera, because for each maybe you have changed the camera resolution, so I need to cater for that. So if you change the camera resolution, the code will still work fine. So that's why I'm getting the width and the height, and then I'm reading the credentials. I'm initializing the info dictionary, initializing the background subtraction. This is the status which is going to be false, and it's going to be true whenever someone is present. It's going to be false when someone is not. This is the patience timer, which I just explained. This is the detection threshold, which I told you that I need to get 15 consecutive thresholds. Only then I'm going to consider that person has entered the room. There is actual motion. It's not a false positive. And the initial time, this is the patience timer. Initially it's going to be none, and it's going to start incrementing whenever someone leaves the room. This is the dequeue variable, which stores a threshold detection threshes. So whenever someone is present, a boolean variable will be stored in this queue, and whenever someone is false, the dequeue is going to be updated in real time, and this is going to determine for n consecutive frames a person is present or not. So I'm going to store the status here. Status is going to be true or false depending upon if the person is present or not. This is the FPS initialization. I'm going to start reading frame by frame, and I'm going to call is person present, and I'm going to get the status if the person is present or not, annotated frame, and then I'm going to append this status if person is present or not in this dequeue. And then I'm going to sum all these dequeue. I'm going to make sure that this sum is greater than the detection threshold, and a person is actually detected. And if it is detected and this it's greater than threshold, this is the same thing which I previously covered, that I don't want false positives, but I want to only set the status to true if for n consecutive frames the person was detected. So this is what the condition is saying. And if that is the case, what I'm going to do is initialize the video capture. I'm going to note the entry time, and I'm noting the entry time because I'm going to when I've saved the video, I'm going to save it with a timestamp when that person entered the room. So this is the part that's handling the false negative scenario. So if the status is, I'm saying if the status is true, that the person is in the room, but the current iteration, iteration did not detect that person. So there might be two scenarios here. The person might have exited the room, or the detection might have been missed. So this is what I'm going to do is check the false negative scenario here. So what I'm going to do is start the initial time, start the patience timer, and then I'm going to check from time and time again if the initial the timer has exceeded that patience threshold value, and if it has exceeded that patience value, then and only then I'm going to set the status to false. I'm going to note the exit time. By the way, this is the format using datetime.datetime in Python gives you the exact format. So you can have multiple different formats, and there's a whole doc on how to set the format. Right now, what I'm getting is the day, which is the exact day, Monday, Tuesday, Thursday, and then I'm going to get the month, the date, and the year, the time. So you can change any format that you want. Anyways, so I note the exit time. I release the video. I set the initial time to none again. I set the body, text body alert the person entered the room at and left the room at. So this is what I'm sending the message. A person entered the room at this time and left the room at this time. And this is the entry time which I got from above, and this is the exit time which I got from here. And then I'm going to send the entire message to the person. And again, this is only happening once the person is not detected and the initial patient's timer has run out. So patient timer has exceeded this patient's value. And again, if the person reappears, then we're going to again set the initial patient's timer to none again if the person reappears. So this is the reappearance case that's being handled here. And the rest of the code is pretty simple. I mean, we're just getting the current time, we're putting text on the screen, and then we're putting the changing the text depending upon the initial timer here. And then I'm if the status is true, I'm saving the video frame, showing the video frame, updating the FPS counter, and breaking out of the loop. All right, let's see all of this in action. But before that, let me show the screen here. So this is the file path where the video will be written. So once I start, this, you will see a video appear here, and when this whole application closes, the final video will be here. So and notice the video will be timestamped like this. So I'm going to start this, and then I'm going to open up this cam here. So this is the entire thing happening. So this is the timestamp here. The room occupied is true. It was false when I was not in the room. The patient's timer, see here, the patient timer is falls below 7 when I was ducking here. At that moment in time, the motion detector did not detected me. So this is why the patient's timer fall below 0 here. Notice the patient timer is not going towards 0. As soon as it reaches 0, you're gonna see my video appear here. So as soon as it reaches, see, as soon as the patient's timer fall below 0, my video appeared here. So I also received a message here. So I received a couple of messages here telling me the person entered the room at this time and exited the room at this time with Twilio API. So two things happened here. Video was saved with the timestamp, and I got a Twilio message. I'll show you another scenario where the patient's timer was really useful. So let me show you the main demo of this entire application, and you'll see the patients in action. So in this demo, you're going to see the main, advantage of patient's timer when the person disappears out of the frame. So see this closely. I disappear out of the frame. The patient's timer is going to start, going below 7, and it's going to, start decrementing. And notice here the video is still being recorded. So the video writer has not, exited the video. I'm not going to get a message when I'm going to disappear out of the frame. The same process is still happening, and this is because the patient's timer has not reached 0 yet. And see, I reappeared in the frame again before the patient's timer went to 0, and because of this reason, I'm going to get the same video. I'm not going to get two separate videos for this particular scenario. And this is the main usefulness of the patient's timer. You're not going to get spammed by multiple videos and multiple messages because of the same person. All of this logic is being handled by this particular piece of logic. So that is it for this whole application. By the way, when you download this notebook, you're also going to get this last piece of cell, and this is going to help you record a sample video, because I strongly recommend that when you're coding this sort of logic, you work with a sample video, not with the actual stream, because you're not going to get a sample, another person to walk in, and then you're going to analyze the background subtraction and all the things. You're going to need a particular video sample. That's how I coded all of this. I recorded a sample video, and this is the same reason, I'm working with a sample video here. All you need to do for your scenario is that change this, sample video with the actual IP camera link. So what I can do just now is that I can copy this here, and then I'm going to paste this, and I've got my entire application up and running. Right, so this is the final application. So lastly, I do want to cover a few limitations of this current approach. So the thing is, whenever you start the server in this IP camera application, it's going to give you a dynamic IP. So every time the IP is going to change, and to bypass this limitation, you need to set your dynamic IP to a static IP. And another problem with that is that this whole IP camera streaming to your PC is only going to work if both of them are connected to the same Wi-Fi or the same network. So this is another limitation, and both of these limitations can be bypassed by some methods. And I've actually created this PDF for you guys. So these are the details regarding how you can bypass both of these limitations. So because this was a little bit more technical and like more boring, so I like put those details in a PDF format, and you want to get this PDF and you download the source code zip file. So this is going to be included in the zip file. I'm telling you this because if you're trying to deploy a commercial system, by the way, this can be used commercially. This is a very robust application, and instead of a camera, you can actually use multiple IP cameras and add some code to combine those streams and such that. So that is all for this video. Please do subscribe to this channel if you found my videos useful, and make sure to comment. I do reply to each and every single comment, and let me know if you enjoyed this video or not. And I'll see you in the next one. Bye.